based on the two techniques that we are talking of, the hierarchical and non-hierarchical, the guidelines are that if you are to use the hierarchical, then we are looking at less than 100 observations. In the hierarchical technique, we allow the software to decide how many clusters that it would create. So the software will take over and make that decision. We can also ask for some visual outputs called dendrogram or scree plots that shows how the clustering has occurred, how the software has done the clustering, which items were selected or which proteins were selected for the clustering. The next one is the non-hierarchical. The non-hierarchical, for us to use it, the guidelines are that we should have at least greater than at least 100 observations. So it should be greater than 100. Under the non-hierarchical, we will instruct the software how many clusters to produce from input parameters we provide. So we will partition the observations into number of clusters, and each cluster should have some observations. So when we say these are the clusters, because we instruct, and ultimately each cluster should have observations. The way it works is that it computes the mean or the average. In cluster analysis, it's called the centroid or the seed point of each cluster. And in the iterations that it performs, it takes the center or the centroid or seed point, and then it looks for any observations that are closer to that seed point and then recluster it. If you take two classes, say one class has average mark of 70, the other class has average mark of, let's say, 90. Now in both classes, there's a spread over the average. So 60 will have its own spread and 90 will have its own spread. So when you give all this information, the input into cluster analysis, right, we'll look at each classroom and find out that this class has average of 60, the other class has average of 90, and then it has a spread. And in the regrouping, what it does is, it will take the 60 and then look for anything closer to 60 and from both classes. So when we are talking about cluster analysis, there could be several inputs that we are providing, maybe just not 2 classes, maybe 100 classes like that. And it will look at all the input that we have provided and take the averages of each class to start with, and then look the student marks around that average, and then it will create new clusters. And then it come up with average of 60, average of 90. When it creates averages around 90 and around 60, then there are others who are left out. Then the cluster analysis will look for the centers for those who are left out. And it will look at the spread of those who are left out, and then it will create new clusters, maybe another mark average of 65, 85, and so forth. So it will create these clusters, but it is non-hierarchical. Now, if it is non-hierarchical, it will not scaffold to create a pyramid. And this will be performed, number of iterations will go through. Because we are instructing how many clusters it should provide, it will try to optimize the number of clusters. So it will take the input observations and look the best possible solution for us. Let's say we want instructing 3 clusters to be performed, to be given as output. Then it will look for the 3 best clusters. So not necessarily it will be the averages that we have provided, because now that input parameters, input observations are there, it's not assuming anything. So like in categorization, it will not try to categorize with a predetermined information. It will look at information fresh, as in there's no averages to start with, and then it will start clustering and come up with the best possible solution that could provide for the inputs that we have given.